Welcome to Barrington Area Conservation Trust's Conservation Conversations video library. My name is Kat Gertz, Administrative Director at BACT, and I am your host for this companion series to our podcast. Today, we're talking about soils and native landscapes. Leonardo da Vinci said that we know more about the movement of celestial bodies than about the soil underfoot. This may be true, but at BACT, we are working hard on fixing that. Our vision is to promote voluntary private land conservation that benefits communities and natural systems. There are more than 1,700 land trusts across America. BACT aspires to expand the pace of land conservation while also providing hands-on learning and volunteer opportunities. Check out our very first podcast, Let's Talk Conservation, to learn more. Very broadly, here are some examples of the general types of ecosystems that BACT stewards. So, what exactly is stewardship? Stewardship is the activity or job of protecting and being responsible for something. At BACT, we steward our own properties, such as Peterson Preserve, which is a cross-county line from Barrington High School, as well as guiding private landowners to steward their own properties. How we steward the land is driven partly by the type of soil found there. The soil composition of a wetlands is going to differ from that of a mesic prairie. A cold, dry climate is going to have a different soil composition than a hot, humid climate. And the original parent material the soil developed from is also key, be it granite, sandstone, limestone, or something else. Soil is made up of basic building blocks: mineral matter, which are the rock particles formed from the bedrock and weathered rock. There's air, which is found in the pore spaces between the rock grains, along with water. And then there's organic material: humus, which is a black sticky gel produced from decaying plant matter and animals, as well as living organisms: earthworms, beetles, fungi, bacteria, and more. The Uden-Wentworth scale was developed in 1898 and expanded in 1922. It is a geometric scale of grain sizes which classifies sediment size from 4,096 millimeters down to 0.00006 millimeters, boulders to clay. Okay, now let's make some soil. We're going to start with the topography of a region. We're going to add the parent material that exists there, and the organisms that live in that material. And then we're going to add the climate. Is it cold and dry or hot and humid? And then we're going to add time. In a cold and dry climate, it will take 1,000+ years to form just 1 inch of topsoil, while in a hot and humid climate, it takes just hundreds of years. Now let's look at the actual layers of the earth. Soil is a mixture of rock and organic remains that usually cover a form of bedrock. The weathering of the soil produces what's called horizon layers. The top layer is usually the best place for growing plants. That's the one that's the most rich in that humus made of organic remains. Every soil has a profile. From the top down, we start with a layer of dark, fertile humus made of rotting plants that lie at the surface of the soil. Underneath, the topsoil horizon contains plant roots and plant and animal remains that bacteria and fungi are helping to rot down. The subsoil contains fewer plant and animal remains, but has plenty of minerals. And below are the rock fragments, then solid bedrock, the original parent material source. This graphic illustrates the development of those horizons, those layers of soil. Introducing drummer. Along with the Illinois state bird, the cardinal, and the state flower, the common blue violet, we have a state soil. Drummer soil is perfect for growing white oaks. That's our state tree. Let's take a closer look at the weathering process. Without transporting them to another location, weathering breaks down rocks and soil through the action of wind, water, and temperature. I think you'll be really familiar with this particular weathering process that occurs a lot in northern Illinois. Brr, frost. When water freezes in rock crevices, it expands and it splits those cracks just a little more. In time, the rocks will crumble. Erosion is different from weathering in that the material is not simply worn away, but is actually moved from one location to another. Many of the same forces involved in weathering can be responsible for erosion. Modern agriculture contributes to erosion by laying bare vast acres of soil to the elements. At the mercy of rain, this soil is washed into nearby waterways. Current estimates show that 90% of our topsoils are thinning globally, and the topsoils on conventionally farmed lands may last less than 200 years. Do you remember how long it takes for topsoil to form? Hundreds and even 1,000 years. Planet Earth cannot regenerate as fast as our topsoil is thinning. In the 1930s, agriculture in the U.S. Midwest removed the native prairie grasslands and planted huge fields of crops. A subsequent drought caused these crops to fail, leaving those acres of land bare. The winds blew that exposed topsoil from areas like Oklahoma all the way to New York. That's wind erosion at its most extreme. Well, if this is how we maintain our shorelines today and it's leading to erosion, just what can we do differently? These are two of the man-made options for preventing erosion. They're effective, but not very pretty. Shorelines in nature are not naked. Plants will grow all the way down to the waterline. So when humans clear those water edges of vegetation, the movement of the waterway erodes the banks. Planting native water-hungry plants along the shore will stabilize it, although I do feel like maybe it shouldn't be done in a straight line. Now this is what a native shoreline should look like. Get ready to meet some of these native plant superstars. Exactly what is a native plant? Generally speaking, they are plants that were found in an ecosystem prior to European settlement. And why is it so important to plant native varieties? Why not plant just any old plant? Because native plants will grow with minimal or even no use of water, fertilizers, and pesticides because this is actually their home. They are built to live here. Check out these roots. This is what goes on beneath in the topsoil. On the far left is turf grass, the lawn around your home, your school, office buildings, golf courses, and more. A monoculture of non-native grass with 2 to 3 inches long roots. Compare that to the roots of the native prairies. Which do you think will be more effective in stabilizing the soil against weathering and erosion? Let's make these measurements more real. The average height of a male in the U.S. is just under 6 feet. Let me introduce you to prairie dropseed. This is a native grass that thrives on the prairie, and their coriander-scented blooms float above the slender grass stems in late summer. Coneflower blooms in early summer, and these are a favorite nectar source for pollinators such as butterflies and hummingbirds. Despite its name, this drought-resistant sunlover is not a weed. Indigenous peoples chewed this fragrant resin produced when it was in bloom like chewing gum. And here is our superstar, blazing star. With its 15-foot deep roots, loves full sun, dry conditions, and poor soil. Native plants perform their jobs incredibly well and look gorgeous while doing so. Plant roots themselves are another hot topic. Here is an example. I love this picture. Agricultural plant roots on the right, that would be wheat, corn, soybeans, versus native plant roots on the left. Not only are the agricultural roots not as effective at combating weathering and erosion, but being smaller has another impact. Roots sequester carbon. Has anyone heard of climate change? The carbon released in the atmosphere by human habitation is a key component of this threat to the existence of life on Earth. That's a bigger conversation than we have time for here, but let's talk about how roots help to mitigate that carbon. Remember the 2 to 3 inch turf grass root. That's going to do very little, particularly when we factor in the lengths to which we must go to keep this non-native monoculture growing: irrigation, fertilizer, herbicides, pesticides. Agricultural plants, they have a bit better of a root, but we pull them out at harvest, releasing the carbon that they sequestered right back into the atmosphere. Many people say, plant trees. Yes, a tree maintains a root system as extensive as its canopy, but in the space of one tree, hundreds of native prairie plants with deep roots can sequester even more. And finally, let's take a look at the soil food web. This is a community of organisms living all or part of their lives in the soil. It describes a complex living system in the soil and how it interacts with the environment, plants, and animals. Food webs describe the transfer of energy between species in an ecosystem. The trophic level of an organism is the position that it occupies on a food web. As organisms eat, grow, and move through the soil, they make it possible to have clean water, clean air, healthy plants, and moderated water flow. There are many ways that the soil food web is an integral part of landscape processes. Soil organisms decompose organic compounds, including manure, plant residue, and pesticides, preventing them from entering water and becoming pollutants. They sequester nitrogen and other nutrients that might otherwise enter the groundwater, and they fix nitrogen from the atmosphere, making it available to plants. Right here in Barrington, BACT is doing things to maintain soil health and restore native vegetation. Hey, hang on. Did someone drop off a bunch of flies at Peterson? Nope. Fly dumping is when a hauler does not want to take the time to bring in a load of debris to a landfill. Instead, they sneak into a field and dump their load on the fly. Frost heaving started revealing extensive trash in the Peterson Prairie, including chunks of concrete, pieces of clay drainage pipes, and more. In summer of 21, we brought in the big guns, dug up the garbage, and then leveled the soil and reseeded the native plants. They had already started sprouting by the fall. We hope you enjoyed your tour today of native plants and their soil. Follow BACT on these social medias and subscribe to our newsletter on our website. And listen to our podcast. These episodes are made possible by a grant from the Barrington Area Community Foundation. Thank you.